All right, so question number two says examine the following state transition diagram. Complete the reference table with the diagram. Now, of course, very quickly, guys, state transition diagram is something which you should be aware of, before solving this paper. But as the name suggests, it's going to keep a track of different states that a particular system can be in, and the important thing is that how the transitions occur. Right, so the transitions, for example, each arrow is actually showing a transition. For example, this is showing from S1 to F2, it's going from one state to another on, a certain input, on a certain stimulus, on a certain input that is low level. And what will it do if that particular input is that is usually shown with this slash. So it says if low level it is detected, go on and activate the pump. So similar situation is for the remaining of the stuff. And I hope you guys know about it. But if not, it's pretty simple and straightforward. As I said, that you transition from one state to another, and there are just few things: input, okay, like on based on what particular input you're going to transition to a particular state. The second thing is that what is going to be a particular output based on a certain input, just like if there's low level detected, go on and activate the pump. And the third thing is that there are going to be certain inputs which are going to make you keep in the same state. So it says that you're going to stay in state 2, S2, if low level is detected. Similarly, it says that in fact there is no other similar situation in this particular example, but there could have been something like this, that maybe an arrow over here telling that if any particular input, just stay in this particular state, so on and so forth. Anyway, so let's go on and have a look at the question. It says the number of transitions that result in a different state. So essentially, how many transitions or how many inputs that we have, which is going to cause me to go to another state, from one state to another. So let's just have a very quick look at it. So I think what makes you go from state 1 to state 2 is low level detected. So that's the first one. Um Normal level detected makes you go from state 2 to state 3. So that's second. And the third one is normal level detected, which makes you go from state 1 to state 3. So the number of transitions that result in different state, it's 3. We would not count low level detected over here. Why? Because it's not making you go to another state. You're actually still staying in within the same state, which is S2. The number of transitions with associated outputs, I just explained it to you, that the way usually, when things are written on top of your the state arrows, which are going from one state to another, they actually show what they actually show, what's the input and what will be the associated output for that. So we can see that there are only two transitions which have associated outputs, which is essentially if low level is detected, go on and activate the pump. If normal level is detected, go on and deactivate the pump. So it will be two. The label that should replace X, well, of course, that's going to be start. Simple as that. And the final or halting state, guys, you can clearly see that the halting state is S3. Why? Because you can see that this is the state from where you're not transitioning anywhere. You have a look at this. Once you reach state 3, you are not going to go anywhere. It's just going to stay there. So S3 is the final state. All right, so it says the current state is S1. The following inputs occur. Low level detected, low level, low level. Give the number of outputs and the current state. So, uh, just a sec. Yeah, so what essentially is happening, it's saying that what is going to happen is that once you start off, you have these particular inputs. The following it is low level, low level, low level, low level. So let's try to go through this. Pretty simple. You go into this, if low level is detected, you will go into this particular state and it's going to cause you to activate the pump. And then again, if low level, you stay in the same one, then other low level, you stay in the same state, then other low level, you stay in the same state. So the number of outputs are going to be one, and the output is essentially going to what? It's going to be the activate pump. And the current state is going to be S2, because you remember we are not going anywhere beyond S2 based on these particular inputs. Okay, so it says a system is but being developed to help manage book loans in a library. Registered users may borrow books from library for a period of time. All right, guys, questions like this, they are very, very, very much open-ended, and most of the time they are very much dependent on our particular perception of a certain example or a certain problem that is at hand. Um, but at the same time, what you've got to do is that you also have to remember that um, it's important to go through a general thinking and general remembering process to ensure that what would I do when a certain situation comes up. Think like a developer, think like not a developer, in fact, think like a planner, a manager, and think about what would you do. So if you have to, let's say, create a system in which you're going to manage book loans in a library, what do you think should be stored for each loan? Be specific. Don't miss out on such important stuff, and don't just end up thinking about, I don't know, everything. All right, what you got to do is that, remember, it's talking about each loan. So very simply, it says a system is being developed to help manage book loans, may borrow books from the library for a period of time. So that must be stored. Obviously, one very obvious thing is going to be the user ID. Okay, which user is taking the loan? All right. Which user is actually taking the loan? So that you need to know the details about that particular, user. Okay. The second thing is obviously going to be which book are you going to loan? So I will go with book ID. We can go by book title and everything. You can go by book title or book number, but ideally we prefer having IDs because I hope you remember that this the user ID or even the same thing with your book ID is that they're going to be unique. All right, because remember, I mean, yes, this might come into your mind that okay, when do you see two books having the same name? Well, yeah, ideally this doesn't happen, but think about the fact that, let's say, maybe the library has five computer science books, the same author, because they know it's more in demand. So if you're going to store them with the same name, you will not keep a track. So that's why having IDs they're important. So just make it a habit whenever something comes up, keep ID factor in your mind. User ID, book ID, any other situation, I don't know, teacher ID, school ID, etc., etc. All right, and there could be a lot of things that we can add to this, but obviously one very obvious thing you can say is could be the duration, could be duration of the loan, like how long are you going to loan the book, or what could be is, I would say, is the start date or the end date. you know of course, usually what you want to do is that you would want to put it up as one thing. If you store start date, end date, you would not really want to do duration of the loan or vice versa. So there could be a lot of things. There could be something else as well. You can actually go on and store what's the start date, what's the end date, so on and so forth. Anyway, set one item of data that will be required in the library system but does not need to be stored for each loan. Well, now there could be now a lot of things. You do not really need to store everything in for each loan, but it has to be a part of the library system. So it could be anything. Generally, it could be details about the user maybe. So it could be like contact details of the user, like phone number or email, or I don't know, maybe a student ID or an ID card, or maybe address, etc., something like that. Or we can also think about, we can have the book details, which obviously have to be stored in the library system, but they are not needed for the loan. Alhamdulillah, sorry about that. So yeah, book details, they have to be stored as well. I don't know, maybe the author, maybe the book number, which is the ISBN, etc., etc. Okay, so it says one operation that manipulates the data stored for each loan would produce a list of all overdue books. Identify two other operations. Now, one operation that manipulates the data stored for each loan. So whatever operation, obviously you can think of a lot of operations, but the operation have to revolve around the fact that you are, manipulating the data stored for each loan. So I think the most obvious one, the first one, would be create a new loan. Okay, so create a new loan when issuing a book for borrowing. So that's the first thing, that when you're actually going on and going to issue a new book for borrowing, you'll have to create a new loan, which is going to make which is going to make a new operation, which will manipulate the data for each loan. And also another thing would be, checking loan history for a student slash book. So, if you want to check if when a particular student is actually, or a particular user actually is taking, because it's not necessary that it's just going to be like a student, any user essentially. User would be a better word, I would say. So a user or a book, that if they've already taken a book or not, or whatever, something along those lines.